As you can see that this person is producing the two water waves by using the two balls on the left and the right hands. And depending on the time that he's produced the waves. So if I start making a wave using the right hand with certain frequency, but my left hand is still stationary, it does not move yet, okay? But then at a later time, both hands move oppositely, like this, up, down, up, down. So the difference in time that I generate the two waves determine the difference in the phase of the two waves. So the phase here is the state, the condition, and those things involves the displacement of a particle at that moment when we measure that displacement and its velocity and energy. So if I move the wave like this, so that they are coincident, they're identical. The two graphs are identical, starting at the same time and decrease and increase at the same time. We say that the two waves, the red and the blue waves, has zero phase difference. Okay, and then if I change the red wave here a little bit, like this, and the second wave, like this, so that when the red wave is maximum and positive, which means its displacement, for example, the wave on the water surface, at that moment, at the position that I measure the displacement of that wave, it is a peak on the wave on the left, for example, okay? And for the blue wave, it is a trough, a dipped place at that moment. So you see that the red wave is decreasing and the blue wave is increasing oppositely to each other. And in this case, we say that the two waves are different in phase by 180 degrees. They are opposite in phase. And if I move the wave here to another place, signal here, okay. So the second wave, when the first wave, the red wave is 0, the second wave is maximum like this, it is 90 degrees different in phase, okay. The relationship is the phase difference is calculated by the difference in time. When you compare the peak, you know the difference in time delta t. For example, here, this is the time t1 of the first wave, the green wave, and this is the time t2 when the second wave is at its peak, okay? And the difference in time t2 minus t1 is what you need to measure or calculate or observe from a given graph of the two waves, okay? And then you take that time difference, delta t, and divide the period. In this case, the two waves have the same period and same wavelength. We are not dealing with the cases that the periods of the waves are different, okay? And same lambda, of course. Taking this ratio, the difference in time between the two peaks and the period of the two waves, and then multiply with 2 pi, you get the phase difference delta pi. Comparing the peaks of the wave A is here at 0.2 seconds. And then the peak of the other wave is here at 0.7. So the difference in time between the two waves, the two peaks, is 0.5 seconds. And then we need to compare this difference in time with the period of the wave. Period. They have the same period, the same frequency. Huh? Yeah, you can see, okay, the period calculate from this point. The period is 0.8 seconds. And for the other way, it's also 0.8. You can see from this point to this point. Yeah, 0.8 approximately. And therefore, the phase difference is calculated by taking the ratio between the time difference, 0.5 second time delay between the two waves. Okay, time delay, and then divide the period, 0.5. The period is 0.8. And then this is the fraction, okay, and then times 360 degrees to get the phase difference. So that is 5/8 of 360, and the result is 5/8 of 360, 225. Again, we do not have that angle, but equivalent to adding or subtracting 360 degree, like the other question that I told you earlier, like from in the beginning of this session. So when you subtract 360, 225, subtract 360, you get the answer 135 degree. So that is the method to find the phase difference. Check the answer, and then I will erase this thing and ask you to do again. Summer 20, paper 1-2. Summer 20, paper 1-2. Question number 22. Okay, by the way, in a paper 1 question, the order of the question from 1 to 40 is arranged in the order of the topics that you learn in the syllabus, from kinematics to dynamic to Newton's law, energy, momentum, and then to thermal physics and waves, in the order that you study in the school. So usually the question about wave is in the middle. Question number 22, 23, etc. 22, huh? Answer C, 135 degree. Okay. I erase it. Do it again. Make sure that you can do it yourself. Many students of mine I know, they told me that they understood after watching my solution, but turn out when they do the test, they mess all up. So I have to ask them to do similar question again many times. Many similar question.
How do you get the angle from 5/8?
Times, not plus 360. Times here first. To get the angle of 235, 5/8, and then times 360, you get 225 degree. This is the phase difference, and equivalent to 225 minus 360, or vice versa, 360 minus this value, and you get the answer 135 degree answer. So if the option ABCD involve this value, you can choose that directly. But if it does not involve this value, you need to convert it using the angle here. Okay. Like the previous problem, we have 100 degree phase difference, it equivalent to 260 minus. Okay. Again, like in a unit circle, you have an angle, and then you rotate it 360 degree, you get the same angle. Cosine of x is the same as cosine of x plus or minus 360 degree.